Good afternoon. Thanks. My name is Leonid, and I'm working in JetBrains in Kotlin team, that part of the Kotlin team which works on libraries that you love, like Kotlin standard library, Encoder, coroutines, and of course KOTLINX.SERIALIZATION, about which we are talking today. So maybe some of you are already using this library. Raise your hand if so. Yeah, not very much, guys. Also, there are some. But I think that the whole area will raise a hand if I ask this question: do you need to parse JSON in your work? Yeah. So if you go to our GitHub and open a README, you will see that KotlinX.SERIALIZATION pretty looks like a regular JSON library. We have some objects that represents JSON with some configuration, etc., etc. And we, of course, have methods to parse an object from the string to Kotlin object and to stringify it from Kotlin object to a JSON string. So the question is, why do JetBrains and Kotlin need yet another JSON parser if we have guys like Jackson, like Moshi, like JSON, and so on and so forth? There are tons of them. So the answer is pretty simple, because these all are Java libraries. And Kotlin now is more than Java, more than JVM. First of all, of course, KotlinX.SERIALIZATION is a multi-platform library. It supports all three backends of Kotlin, JVM, JS, and native. If you are using KotlinConf application, then you're basically using the code that was written using KotlinX.SERIALIZATION. So the usage is pretty simple. You just declare your model in your common code, mark it as serializable, and then it works on both platforms. You have JSON, protobuf, so on and so forth. But that's not the whole reason. Another important fact that this library is Kotlin-oriented. And well, basically, Kotlin has 100% interoperability with Java. But in some edge cases, Java libraries can give you not the result, not expected result. So let's look at this very simple data class. We have one field which has a string type, and another field which is also a string, but it has default value. So when we try to parse such JSON, which contains only the first field, and the second one is optional, we expected our class to be with data full and optional data with string empty. But if we try to parse this class with a JSON, which is a famous Java library, we will unexpectedly see that optional data is null. And that's because it wasn't in the input string, and JSON doesn't know anything about optional fields in Kotlin. So that's the big problem, even not because we have a null instead of empty. It is because when we have this string without a question mark, Kotlin compiler should guarantee us that we can never see a null in this field. And even if we put null somewhere there, somehow there, like via reflection or via Java deserializer, it will break our program in an unexpected way, maybe in some other module where we pass this class, and we will debugging this for 1 hour or 2 or more. This is very bad. And of course, if you parse this class with KotlinX.SERIALIZATION, it will give you correct result with a string empty. Another point of our design which distinguishes us from other libraries is that our serializable classes are always explicit. We have special annotation for them. And if your class is annotated in such way as serializable, then it means that you have a special declaration on it. On its companion called serializer, which gives you a k-serializer. Yeah, it was very hard to pick different words for that. So you can use this serializer to parse or stringify classes or to convert them to other formats. And you always know that if you have a k-serializer in your hands, that you can do something with this class and get some predictable output. And on contrary, if you try to use some implicit serialization when you don't pass a serializer, like in this case, with parse just from input string, the compiler and the library warns you about experimental declaration. It says experimental implicit reflection serializer. And as you can guess, it means that this decoration using reflection. And we try to avoid this especially because you know that reflection is some Java-specific thing, and it, of course, won't work on native correctly. It almost never works on Kotlin.js. And, of course, it doesn't work for collections because, as you know, generics in Java are erased at runtime. So when we try to parse a list of data, all we know is that it is a sum list, but we don't know if it is a list of data. And if you remember, again, JSON, when we try to parse a list of something, we need to pass a type token there. But it's a big, nasty thing. It creates an anonymous object. It is a long string of code, and so on and so forth, which is not very convenient. And in KotlinX.SERIALIZATION, you can use provided combinators on the serializer. So data serializer gives us a k-serializer for data, and .list just converts it to the serializer of lists of data. And it's very short and simple. So combining all this together about explicitly marked classes and no reflection, it gives us actually even compile time safety. So let's say that we have some class called complex data, and it has inside of it some complex class which is not serializable, not marked so. So when we try to write this declaration, a compiler will emit an error and says that serializer for this type has not been found. And it is even an IDE diagnostic starting from recent version of Kotlin. So if you remember Java serialization, it also forces you to have all classes implement serializable. But this was a runtime error for Java. And in Kotlin, we have this compile time error, which helps you catch the error earlier, basically. Another key point of KotlinX serialization is pluggable formats. So I said that we have this serializer. You always have it when your class is marked as serializable, and you can use it in different formats. For example, here we have JSON and protobuf. They, completely different formats, string and binary, schema and schemaless, but they use the same serializer. And basically, this gives us the same API. You just need to replace word JSON with protobuf and replace corresponding functions. That's all. So how we came up with this design? So basically, we draw a distinct line between serializer and the format. So serialization in our terms is just a conversion from a Kotlin class to a so-called stream of primitives, which may be int, strings, and so on. I don't mean primitives in JVM way, because in our terms, string is a primitive, but actually it would be just silly to split it as an array of chars. And the serializer performs only this conversion, which means it shouldn't know anything about format, like if it's binary or string or so on. So it's only responsible for some Kotlin-specific thing, like class metadata or handling optional values. And the rest is done by the format, which converts a stream of primitives to an actual result. It can be string or binary. It can have versioning or does not have. It can be and can require schema, doesn't require, and so on and so forth. There are a lot of serialization formats in this world. So of course, they have different specific configuration. We have a big configuration class for JSON, which supports non-quoted or quoted, if you want format, print your JSON or not, and so on. And protobuf doesn't need this flags, and so we can create it right away. Some of you may already ask questions like how can serialization be reflectionless, why it does work on native, how can you get compile time errors if so. Okay, let's see a bit behind the scenes of KotlinX serialization. So why we need both serializable and apply plugin thing. So if you annotate your class as serializable, you know that you can get a serializer with a special declaration, which is declared on its companion. But you never wrote it by your hand. And if you comment out serializable annotation, you will get unresolved reference error, which means that this, like not a regular compiler error, this method just disappears from the class. And if you forget to use this line in your build script, apply plugin KotlinX serialization, you will get this nice warning in your IDE, which says KotlinX serialization compiler plugin is not applied to the module, so this annotation would not be processed. Actually, this is a recently added warning, so before that, you would also have an unresolved reference error. So we can say that Kotlin serialization consists of a compiler plugin and a runtime library. Definitely have some plugin because we need to apply it. In Gradle, IDE knows about it. And so what is a compiler plugin anyway? The thing is, no one knows what a compiler plugin because Kotlin does not have a public compiler plugin API, but it has some, I don't know, extension points which you can use or we can use because code base is constantly updating, and if you don't have your plugin in the Kotlin repository itself, it would be very hard to maintain it. But because we have all the officials plugins in the same repository, it is much easier to write them. So, of course, KotlinX serialization is not the only compiler plugin. I think Android users are aware of Parsevalse plugin, and some actually use them. And Spring users are aware of Kotlin All Open or Kotlin Spring plugin, which magically turns all the declarations, not all the specially marked declarations, to an open classes. So it is possible, but it is still a big magic. So how does a compiler plugin work anyway? If we try to represent a Kotlin compiler in such a simple scheme, we can see that we have a front-end part, which performs parsing of source code and resolution, type inference, and so on. And we have 3 different backends for JVM, JS, and native. So serialization plugin actually affects all of these parts. On front end, it says that we now have a .serializer function on companion. And when the compilation process steps down to backends, compiler notices that it has a declaration that does not match any source code written by user. And it means that plugin is responsible for the declaration, and plugin comes and does additional code generation. But to understand what plugin generates, we need to try to write a serializer by our hand. So if we open a new class, a new file in IDE, and hit and implement members on a KSerializer, we will see that we have some serialize and deserialize methods. Again, it's not that simple to invent different forms for that. And as an arguments, we have encoder and decoder. So if you remember this picture, we understand that we are somewhere here. We are writing this arrow, and we should communicate with this guy, which is a format implementation, actually. So which methods does encoder have? There are a lot of them. But if we cross out the same part from each method, we will see that it's basically just one function for each primitive data type, like byte, short, int, long, and so on. So how we write our serializer? Let's solve some simple task, like we have a data class color with 3 components, and we want to convert it into the single string, which is basically color hash code. So we write a serialize method. We first compute our string we want to write from the components to hex code and concatenate all that. And then we can just call encoder and say encode string with our string, and that's basically all we need to do. And big plus of such an API is that encoder is a format abstraction, so it would work the same way in protobuf, JSON, XML, YAML, and any other formats you can imagine. Also, this is a common code, so it would work in the same way on JVM, JS, and native. So you can write your serializer one time, and it would basically work everywhere with every format you want. So if we want to solve another task, like compose 3 different components from JSON to one class, we could try and see if similar approach works for us. So we have our result here, and then we just call decode_int 3 times with shifting each component, but it actually wouldn't work because we don't know if we get JSON which always has a red component as the first. So if it would look like green at the first place and then red on the second, we will get incorrect result because we just decode in the same order always. So how we can solve this problem? For structured data, we have a special interfaces called composite encoder and composite decoder. They're basically the same, except they have an additional parameters like, and these parameters are SerialDescriptor and integer index. Well, we will talk about descriptor a bit later, but you should know that this descriptor provides basically metadata about the class. And index is basically our component we are looking at. So how to write a proper deserializer for such class? We should first convert our decoder to composite decoder by calling begin structure and end structure. So these points are basically marking the begin and end of the class. For in JSON, begin and the end are obviously curly braces. In XML, this would be an opening text. In protobuf, it wouldn't be anything because there are no splitters. And again, you shouldn't be bothered by this. All you have to do is to call these methods correctly, and the format implementation will do the rest for you. So then we have to write a loop, and in this loop, we'll just get a current index with the code element index. And then if we had 0 index, it means that we have a red component, and we should decode it and shift for 16. If it is a first index, it means we have a green component, green, and shift it to 8, and so on. And if we get a special constant, it means that elements stream ended, and we should go out and call constructor. So basically, this is how all serializers look like. But in real life, we don't need to merge one class into 3 components, or split or merge or do something like that complicated. We all want that we have a data class with 20 fields and have a JSON with 20 fields. And we don't want to write such a loop, such complicated loop for and when with 20 clauses, and it would look like so strange and so scary. So we actually don't need to write this, because this is what serialization plugin generates for us. You can check it by yourself. So pick any serializable class you like, then go to the IDE and find an action called show Kotlin bytecode. And you will see a bytecode in the window to your right. You can actually read bytecode, but I don't like reading bytecode, and so probably you too. You can hit the compile button. So when you hit the compile button here, you will see Java code, because Kotlin can't be decompiled to Kotlin, unfortunately. Kotlin is decompiled to Java. There is more lines than in my previous example, because it's Java, and Java is bigger than Kotlin in such terms. But if you take a good look at it, you will see that we basically have all the same methods that I described to you earlier. So we have begin structure here, decode element index, decode all elements, and then and structure and constructor call. So basically that's all. It's not hard. It doesn't look like magic anymore. It's just some generated code which calls begin structure, then decodes all elements one by one, and then just calls the constructor. And the last part of this a bit complicated thing is the SerialDescriptor, which is basically just metadata storage. So it holds the name of the class, especially fully qualified name that allows us to perform some polymorphic operations. And it contains the table which maps actually indices to property names. So that's how we know that if we encounter data in JSON object, that then we should decode the first zero indexed element of this class, and so on. So this is basically everything you should know about regular usage of library. You can use it. You can even write your own serializers. But if you want to go deeper and write your own serialization format, it is also possible, because library was designed to be extensible by community, by users. And let's take a small look at it. So first thing that we should notice that format interfaces doesn't tell you anything about format itself, actually. So all we have is just encode int with an argument of type int or of type string and so on. And we can do whatever we want with this value. So for example, let's see if we could use this to convert serializable classes to parcelable classes. So if we have some bundle, which is basically k-value storage, we can write a serializable class directly into it without implementing parcelable interface. So how we can do this? We just use library skeleton class, which adds some tag to each value. And basically, the tag by default is just a property name. And then we can just put a value into bundle using this tag. And that's very simple. So basically, just translating calls of one API into calls of another API. And you can even do a multi-platform parcelable implementation. So just say you have an expect class bundle, and on Android it would be actual type alias to android.os.bundle, and on iOS you can use another class or write your own implementation, and it will work in the same way. So another example about you don't have to store values. It's actually if you take a message digest from Java with some hashing algorithm like MD5, or pick anything you want. You can put all the elements of our class in this digest, and in this way you will get just a hash of the contents of this class. So in this example, we aren't actually serializing a class. We just dumping into some black hole, which gives us a hash later. But it still can be performed by KotlinX.SERIALIZATION. And the last example, I actually like it very much, but don't try to do this at home. So if you remember JDBC, we have some things like prepared statement and result set. They are used to communicate with databases. We can try to write an ORM using KotlinX.SERIALIZATION. So let's take a prepared statement and say that we have now a sum encoder which accepts prepared statement. And we can use our class to set an argument in the statement. So basically fill in an SQL query with data from our class. So, and when we have a result set with the response from the database, we can use, again, a decoder from KotlinX.SERIALIZATION to take out like components from this result set and deserialize it to our class. And the last thing that can be useful for us is, again, SerialDescriptor. As I said, it contains some meta information. So basically, we can build not only a representation of a class, but we can also build a class schema. Because SerialDescriptor knows everything about descriptors of properties of this class. So if you have some complicated class like generic data, which contains some description and some content, and then we try to print this descriptor, and with substitution of content like data. So we get this tree, like generic data has content and description, and content also has some data in it. And of course, this tree is annotated, so you have all the types. You have all other data you want. And we can even use it to build a JSON schema of the class. So it's actually pretty simple. You just take a SerialDescriptor, and then for each child of this descriptor, you should build its JSON schema and put it into the big map under the name of the child. So in the end, you just can collect, you can just add the description as a name of descriptor which is actually a fully qualified name of serializable class. And properties would be equal to the properties we collected from our children. So this is not actually a very useful JSON schema, because it even doesn't have optional or required properties. But all this information is stored in SerialDescriptor too. Like you can ask it if it is nullable, if it is optional, which kind does it have, if it is like enum, class, sealed class, or so on. And you can enhance this schema to your needs. So basically, from this class, we can get such schema. So, and the last thing I want to tell you today is the roadmap of KotlinX.SERIALIZATION project. So for now, it is almost feature complete. We have like multi-platform, multi-format core. I told you about and meta information and descriptors. We also have support for multi-platform polymorphism, which I didn't mention today because it is quite a big topic, and maybe I'll do a talk about it sometime later. We also have ID diagnostic. This is the thing that you won't get from any other serialization framework. And of course, since we are Kotlin-oriented, we have special support for objects and sealed classes. So sealed classes is basically like polymorphic classes, but you don't need to stop them in any way because compiler already knows which the whole class hierarchy in case of sealed hierarchy. So what's our next step is inline classes. And this feature is currently in progress because, yes, since we are Kotlin-oriented, we should support them too. And we plan to migrate to integrate serialization tighter with our another multi-platform libraries, cater already has a client, which multi-platform HTTP client, which uses KOTLINX serialization. But we also have plans for KOTLINX.io library, which would be integrated into both Skater and KOTLINX serialization. And then we'll polish the things, polish the performance, so on and so forth. And a release would be sometime near Kotlin 1.4. Because the library is now experimental, it means that API are evolving pretty fast. So you should read change logs, deprecation notices, but it's, I can say, rather stable in terms of production using. And because there are a lot of hundreds, thousands serialization formats in the world, and Kotlin team is pretty small, I hope that community can use our framework and extend it and write your own formats if you need so. So thank you. I remember to vote this thing. I inserted the slide because I was asked to. And I think we have some time for questions.